Hmm. 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 Why is this not updating? Oh god, not that. Hmm. Why is this not working? Hmm. Says I'm not live. No, I am live. Cool. Well, hello. Normal minutes of confusion before anything starts. And I don't know where my dashboard is still, but this is okay. So, kind of my plan to start off was to remind people to sign up for the AP test, because technically the date was the 24th, but that got moved back a little bit because of all the snow days by the people. By Ms. Armstrong. Uh, so I was going to talk about some potential for AP test shifts. Um, so, yeah, this one. So yeah, I just got an email from Ms. Armstrong, who's in charge of AP testing, saying that a bunch of AP tests are probably going to get moved back, depending on what us teachers vote for, slash maybe also what you guys vote for. I don't know if it's being sent out to parents, but for many of these, like especially the ones early on, like Gov or Environmental Science, if you're in that first week of AP testing, um, you are likely or maybe going to have your tests move back to the middle of May or the end of May here, which really affects us fairly significantly because this is gonna have to make me reevaluate what I do about that test that we take afterwards. I figured we'd have impacts because of the snow day, and we're already not having a Unit 6 test. But this may also affect another test, so I gotta figure out how I grade this class um, to change that. But yeah, just know that this is coming regardless of your AP class. For us, it's less impactful because with Calc AB, if we end up moving back, we're only moving back really like a week and a half. So it's like a way bigger deal for environmental science, gov, lit, chemistry, those sort of classes. So like the folks in AP chemistry are probably ecstatic right now. Yes, I realize that there's overlap, and so does Ms. Armstrong. She said that's not that big of a deal. It's possible you take two in one day, but that's already something that kind of happens. And it's possible that the AP people would give us a larger window, and you could take one the day before and one that day or something like that. So Ms. Armstrong said it's not a big deal that there's overlap. Likely you'd be taking them the same day if they both get pushed back. Now, there's still some probability that we don't get pushed back. So I'm going to keep rolling like Tuesday, May 14th is when we're taking the AP exam. But the point is there could be an adjustment. in that schedule. So as long as you know about this, and you know, if you're in like Chem or Gov, you can be fairly certain that your teacher is going to opt for that 2.5 weeks later date. Okay, and then I was going to show how to sign up for the AP test in case you haven't already. You go to Liberty High School's webpage. We do have 66 people signed up, which is pretty respectable. We're at about 2/3. So if you click on academics and then go to AP, I can do it. Maybe I can't. No, we're chilling. I just clicked on academics. No, we're in trouble. Dang, apparently this is not as mobile friendly as it seems. I was doing this really well with the keyboard earlier. Well, this was extremely impressive. Let's go. Come on, click on advanced placement. Lord of Goshen. Well, if you click on, here we go, advanced placement, you get to this page, and then you just click on this total registration link, and boom, you're just typing in your email, your last name, your first name, your ID, and then you just go through this process. And that's literally it. So if you haven't done this, please do this now-ish, or, you know, over the next couple days, since technically the 24th was the first due date. It's now moved back to the 27th. And the absolute last day is March 2nd, but you have to pay an extra late fee for that. So don't do that. Also, there is a link on the homepage. Sick. I should have just done that. That would have been cool. Wait, there is a test. Lol. Do you know when the last day of school is? No, still no. I also have not been checking my email very regularly over break, so if they're following any sort of like logical conventions, then the last day of school is June 26th. If they just add 6 days on the end of our year, so that's when to expect for juniors, but for seniors, you know, obviously not. Okay, so let's go to some actual math now that I've talked about all that garbage. Oh yeah, it's already open. So yeah, there was this quiz that I handed back only to the A Day folks, because they're the only people I saw last week. And we should probably talk through some of it. I think this is the B Day quiz. I only saved one version of it because I'm unprofessional. But I just figured I'd run through this because, hey, it's helpful to see some USEB, and this gives us a chance to do a little bit of USEB. And so in the case where you have a power that's one bigger and a more complicated spot than one that's than the one that's one smaller, you almost always use USEB. So you make u equal to 1 plus x squared. Du equals 2x dx. And you're like, crap, 15x, I don't want that. So maybe let's use some alternate strategies. Let's make du over 2x equal to dx, because that's what you get when you divide 2x on both sides. And then you plug that crap back in, you still have a 15x, but this is u to the 1/2. And dx is du over 2x, so I plug in du over 2x. And then I cancel stuff. And 15 divided by 2 is 7.5 times the integral of u to the 1/2 du. And then you just raise the power by 1 and divide by the new power. So a lot of people divided 7.5 by 3/2 and got 5, which is pretty cool. So the answer was just 5 times 1 plus x squared to the 1.5 plus c. Now, let's see. What did a lot of people do wrong there? They tried to solve this equation for x. the u equals 1 plus x squared equation for x, and then plug that back in while ignoring the fact that dx exists. I ranted about this to the A-Day kids a lot, but the B-Day kids have not gotten this rant. First of all, du really has to be the derivative of u. Second thing is, you always need to have your du and your dx in that resulting term, because you're actually doing substitution for dx. So if you don't have a dx in your u substitution step here, your u substitution sucks. And you're going to get it wrong a lot because you're not actually substituting. So just be very aware of this, that we are actually doing all real math, and we're not actually skipping any steps in these problems. And some people try to, and then can't get anywhere near the right answer, which is sad. All right, so in the second one, if you make u equal to this, du dx equals 1/2 x to the minus 1/2. And this is x to the minus 1/2 dx. Now, the reason why I write the dx over on the other side is because I always multiply it over, which is why it's always like parentheses times this side and then dx, because I'm multiplying the entire side by dx, just in terms of algebra here. But I don't have 1/2 x to the negative 1/2 dx. I have just an x to the negative 1/2, so I have to multiply both sides by 2, and I get 2 du equals x to the negative 1/2 dx, which matches this perfectly, and I can rewrite this integral as u to the 3/2 times 2 du, or I could pull the 2 out. And then you just raise the power by 1 and divide by the new power, and add c, and then plug in what u is again, which I'm going to be too lazy to do this time. There it is. There's u. Plug in 2 plus root x there, and you're good to go. You guys got to work on your sleep schedules. You're like my brother, and you don't want to be 27 and unemployed and living with your sibling. Anyways, he's still asleep downstairs, by the way. I had to shut the door so I wouldn't get bum rushed by his dog. All right, so on to the next question. Taking the derivative of natural log here, you get 6 times du, which is 4 minus 2x, over u, which is 4x minus x squared. There were a ton of people who were just razzle-dazzled by this, like, what did you just do? How did you get that so easy? It's because every single natural log derivative, all you do is the derivative of the inside over the inside. There's no other magic here. It's really not harder than that. If you know that rule, you will get all of them right all of the time. Okay, next one. The really cool trick to doing natural log derivatives is just to pull out the constant whenever you can, because doing u sub here is possible, but not particularly fun, because you have to like divide by 4 and crap. So you can do this. This is fine. But the sneaky way is to pull out a 6/4, because you can pull a 6 out of the top and a 4 out of the bottom. And then this is the integral from 7 to 13 of 1 over x minus 3, which is a really easy integral. So this is the easy way to do this question. You get 6/4 times natural log of x minus 3, and you check in your bounds, which are 7 and 13, so you just get, 10 and 4 in there? Yeah, that's enough of that one. So please be aware that u sub is needed anytime the bottom does not just have an x in it, but you can often finagle the bottom so it does just have an x in it, and avoid u sub. All right, logarithmic differentiation. I was kind of heartened to see a lot of people actually do something resembling logarithmic differentiation in this, and I'm hopeful that that will be true after break as well here. Step 1, natural log both sides. You get natural log of y equals pull the power down. A lot of people want to put a natural log in front of this power, but that's garbage because there's no natural log in the exponent here, and you always just pull down the exponent and put it in front. So just know that the natural log applies to the other term, but not the exponent, because that's like a log rule that you can pull out the exponent out of the natural log. So you get the exponent times natural log of the base. And now you always have product rule here. You get y prime over y equals, okay, product rule, 2 times natural log of 3 plus 4x is a prime b plus a, whoops, crap. All right, we're chilling. And then you just multiply y to the other side, and you get this crap times y. 3 plus 4x to the 2 plus 2x times this stuff. And that's generally the lazy way out here. To just chuck that in there. Okay, that's logarithmic differentiation. Now, that's the quiz. And that's the real stuff I wanted to get out of the way there. But let's pop back to the other stuff I had ready. Oh, yeah. So, the other stuff was to kind of open up more to questions, because we're not really at the end of a unit. We don't really have much we've done this unit. And so I have like my notes here, which are already open. Cool. And so I'm happy to like redo any ones on here. Yeah, we've all taken notes on exponentials, so that's pretty cool. Otherwise, I can just move to doing other types of questions, just kind of ones that I think of that involve exponentials and logs. But I wanted to kind of leave the door open to people. I guess, oh, I should have had the homework open, because that homework had questions that are relevant. How do you integrate constants raised to the power of x? To the x, sure. All right, that was one of the things on that worksheet. So let's go to the sketchpad, dump this garbage from the last stream, and okay. So if you're taking the derivative of 5 to the x, the first step is to realize that 5 is equal to e to the natural log of 5. And the reason why this is helpful is because this gets our bases in terms of e, which is the way we want them. Remember that e to the natural log, those kill each other. That's why these are equivalent phrases. So if I now replace this 5 here with e to the natural log of 5, I get e to the natural log of 5 times x. Okay. Now, did he want me to integrate? Yes. Okay, so we're integrating. So, whoops, no derivative. Integrate instead. Now what we do is, this is a power, so I got to do u sub with it, because it has more than just an x in it. It's a natural log of 5 times x. The derivative is natural log of 5, because the derivative of x is 1. And then I multiply dx to the other side, and I get du equals natural log of 5 dx. Or dx equals du over 5, which is ultimately the most, or whoops, over natural log of 5, which is the most useful of the forms of our derivative there. Because now I can just replace dx in my equation with du over natural log of 5. And this is just e to the u, so e to the u times the u over natural log of 5. And you might be rattled by this natural log of 5 thing, like there's quotient rule here. No, there isn't. Natural log of 5 is 1.7 or something. So we're dividing by 1.7. This is a number. I pull it out, and it's just e to the u du, which integrates to e to the u du. Or e to the u plus e, rather. And then we just plug in u, and we get e to the natural log of 5 times x over natural log of 5 plus c. And that looks like the answer. Now, this can be rewritten because e to the natural log of 5 times x is just 5 to the x. So this is just 5 to the x over natural log of 5 plus c. Which leads to what we're going to talk about after the break here, which is there's a shortcut to this. If you have a number raised to a power, like 8 to the x, and you integrate this, you're going to get 8 to the x over natural log of 8 plus c. You just divide by the natural log of the base. Similarly, if you take the derivative instead of the integral, you're going to get 8 to the x times the natural log of 8. And that's it. You multiply by the natural log of the base if you take the derivative, and you divide by the natural log of the base if you integrate. And so these rules get you through all of these. Otherwise, it's just normal exponential. So that's why when we started the exponential derivatives, I said the first step of every exponential is to exactly rewrite your question. Like exactly rewrite the exponential in your question. And if you notice, in both of my 8 to the x derivatives, I have an 8 to the x in them. And so I'm like super serial about that. Like the derivative and the integral are both 8 to the x, and then multiplied or divided by a factor of natural log of 8. And it's easy to remember whether to multiply or divide because it follows the same rule as chain rule and u sub. When you chain rule, you multiply by the derivative of the inside. When you u sub, you divide by the derivative of the inside. And so it's extremely, extremely similar. So hopefully that helps on that front. Let's see what other questions we have here. Sonia, can you go over 6 on the homework? Yeah, that would imply that I actually pulled the homework up. Let's see if I have it. Let's hope. Oh, I might actually on my desktop. Oh, feels good, man. All right, so where do we get? In this one, I have 20 times e to the 5x over e to the 5x plus 3. So one of the cool things about exponentials is because their derivatives are themselves, you just always go to the thing in the most complicated position and make it u. So if you have an exponential in both spots, don't make the top u, because it's not in the most complicated spot. So I'm going to make the bottom u, e to the 5x plus 3. And if I do that, then I get that the derivative is 5 e to the 5x for doing some chain rule there, and then rewriting the problem, which is how we take the derivative of exponentials, and dx. Now I have 20 e to the 5x dx on top, not 5 e to the 5x, so I got to multiply both sides by 4, and I get 4 du equals 20 e to the 5x dx. And I just chuck this in on top. And so I get 4 du over, oh, the entire bottom was u. Whoa. Weird. This looks exactly like our natural log integral. And that's because it is. So then we just get 4 times natural log of the absolute value of u plus c. And then we chuck u back in there. And we get 4 times natural log of the absolute value of e to the 5x plus 3 plus c. And if you're like super savvy, you notice that e to the 5x plus 3 is always positive, rather. And so we don't need absolute values. So if you saw this on the AP test, you would perhaps see something like natural log of e to the 5x plus 3 to the 4th plus c, because that is the equivalent. It's like putting the 4 inside as a power, and I guess if you 4th power something, you don't need natural logs anyways. So yeah, that's that question. Can you review the second fundamental theorem of calculus from a kid who's not even in my class? Sure! That's a direction for me to go. Let's do some fun second fundamental theorem of calculus here. Let's go from x to x cubed plus x. No, that seems lame. That has potential for being disappointing. Let's go to x cubed plus 1 of, let's make this, t to the second minus sine t over natural log of t dt. And then let's take the derivative of this whole garbage thing. This looks like a pretty horrendous second fundamental theorem of calculus type of question. So one of the nice things about this is even if they're horrendous, they're not very hard. So moral of the story is you plug in x cubed plus 1 everywhere there's a t for that first term. And you're going to get x cubed plus 1 squared minus sine of x cubed plus 1 over natural log of x cubed plus 1. Sick. And then, because of chain rule, because I'm taking the derivative after plugging in this crap, I have to multiply by 3x squared, which is the derivative of x cubed plus 1. All right. So that's the first part. Then I need to subtract, because it is the bottom bound, x plugged into all this crap. So x squared minus sine of x over natural log of x. I need parentheses around that. And then times 1 for the chain rule here, or not. And boom, shakalaka, that is the answer. And we're good to go. Let's see. Have I missed any questions, or have I actually hit all of them here? It looks like I have hit all of the questions. That was a little bit of second fundamental theorem of calculus with about as janky of an example as we could possibly do. All right. Well, let's move into talking about other random questions. Not enough people are awake to ask questions. God, I certainly hope 95% of my students are awake at 1:24 p.m. on a Thursday. Because no matter, like, you have to be up real late to not be awake right now. Okay, so let's think about some questions that would be good questions to ask. All right, let's say I'm taking the derivative of the natural log of e to the 5x plus 17 over, let's make this what's e to the 4x minus 3. This looks reasonable. So let's say you got a question like this and you're trying to think about how to do it. Oh cool, I have another question. But I'll get to that after doing this question. Okay, so this is kind of a combo. I'm doing the derivative here. And the reason why I picked this question is because it has a little bit of exponentials and a little bit of logs, and so we get to try to mess with both of them. So step 1 is anytime I have division inside a natural log, I tend to make those two different natural logs that are subtracted. Because this looks a lot easier. I don't have to do quotient rule anymore. And now let's go. I'm going to do this derivative, and I get du, which is 5e to the 5x, remembering to chain rule my 5 down, which is why there's a 5 here, over e to the 5x plus 17. That's du over u, minus, whoops, I forgot the x in that term. 4e to the 4x for the derivative of the inside here, notably e to the 4x, over e to the 4x minus 3. And that would actually be the answer. We'd be done there. Now, one thing I see is tempting for people, because I saw a lot of made-up natural log rules on my... Oh, crap. I didn't mean to do that. Edit undo. All right. One thing I saw was not to get this answer, but was to instead to say, I can do more log rules here. And I'm going to call this natural log of e to the 5x plus natural log of 17. This is not legit. You are not allowed to switch addition on the inside to being addition on the outside. So please don't do that. This is garbage. Also, trying to selectively apply the natural log, so be like, yo, natural log of e to the 4x, that's 4x plus minus natural log of 3. Right? This is an equivalent. No, it's not an equivalent expression at all. You can't apply the natural log to each of those. In the same way that, like, x plus 4 squared is not x squared plus 4 squared, like x squared plus 16. This is garbage also, because you're not foiling. Yeah, you can't, if there's addition or subtraction inside, you can't split up the natural log. However, you can split up division or multiplication or pull out powers. That stuff's all cool. Yeah, so that's a big set of warnings problem there. Let's do Laura's question, number 10 on the homework. Dun, 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 dun. Okay, I closed it for some reason. Good thinking. Ten is this one. Oh, let's do a little USEB. Sounds like fun. Alright, so make u equal to the thing in the most complicated spot. Ooh. Is this the route we want to walk? Wait, are we taking the derivative here? Am I just being crazy and saying USEB? Oh, I am entirely being crazy. Okay, let's just take the derivative. This looked like a fun integral, though. Maybe we can try that afterwards. See if it's possible. Alright. So, we're taking the derivative, so this is a and b. So I do a prime, 9x squared, times b, e to the 2x squared, plus a, 3x cubed plus 5, times b prime. Oh, okay, so I got a little more going on here. Rewrite, chain rule. Sick. Done. Now, could you go a little farther than this? Yes. And in fact, many times you will want to. So here's what the farther looks like most of the time. So they want you to factor out the stuff that is common to every term. So we got to, like, build every term. So I have to distribute here. So I get 9x squared e to the 2x squared plus... what is this? 4 times 3 is 12, x to the 4th, e to the 2x squared, and plus 20x, e to the 2x squared. Cool, so what's common to every term is, well, 20, 12, and 9 are not cool. They're actually kind of lame. But there is an x in every term, so I pull out an x and an e to the 2x squared. And what I get left over is 9x in the first term, plus 12x cubed in the second term, plus 20 in the third term. And this garbage, you could then factor to find zeros, or just graph that or something. And that would also, that's generally where you'd want to end on this question, is trying to factor this. But factoring a cubic is yikes. So I don't want to do it. I said I was going to do something else after this. Oh yeah, try to integrate this? Let's not do that. It looks like it would be horrible to integrate. Yeah, it looks like it would be horrible to integrate. We need the Calc BC kiddos in here for that. To explain to me how to do, like, Taylor series and crap again. Since I don't remember... Alright, any more questions before I just go and make up some random question again? Do 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 do. Alright. Alright, so let's go make up another random one here. And it's not that random. The integration of that would be like integration by parts. Maybe. That maybe would be part of it. I think there's more to it than that. Do a really janky synthetic division integral. Most janky synthetic division integrals aren't synthetic division because you end up using long division. Like if it's synthetic, it's usually not that hard. Like because I could do like x to the 7th minus 1 over x plus 5, and you know this is gonna get hairy, but it's not gonna be that bad. I mean this is about as bad as it gets. If you have something like this, you have to do 1 and then 0 for x to the 6th, 5th, 4th, 3rd, 2nd, and then 1st, and then constant. Cool. And I'm putting -5 into this whole deal. So I drop the 1 down and multiply by -5 and add. And then multiply by -5, and you see how this is going to get ugly real quick. Luckily, I got my 5 tables down, so we'll get there eventually, assuming it even fits. Oh, cool. Yeah, this is about where I end for the multiplying by -5. What is it? 78,125. So thank you for this, Drew, for this question. So my remainder is -78,125, assuming I did that math right, which, you know, I'm questionable on, but I'm going to believe. Whoops, 26, because I need to add those together. So, if I rewrite this integral, now it's x to the 6th minus 5x to the 5th plus 25x to the 4th minus 125x cubed plus 625x squared minus 3,125x plus 15,625 minus 78,126 over x. And now we just raise the power by 1 and divide by the new power on all these terms, except for the last one, which will become a natural log, and we're done. So yeah, if you can do synthetic, this is really kind of about where this ship ends. There is one other type of question that can be a bit tricky related to this. And it's actually one I've asked in the past, which is why I know it's a bit tricky. So it's one, as I go crazy here, writing the antiderivative of this. I'm going to put this next part on the next line so as to not go off the screen. Whoops, I forgot the denominator was x plus 5. That, oh, yeah, I'm really good at hitting that button today. Is a rookie mistake. Alright, x plus 5. Yikes. And then plus c. And that's about as janky as these could get via the work there. Wouldn't the last be over x plus 5? Yes, absolutely, Drew. I got it. But yeah, so this is some garbage here. So yeah, know that these can be a lot trickier. Wait, did I? Oh no, we're good. That's right. All right. So yeah, that's horrible. And like, who would ever think that this was the antiderivative of x to the 7th minus 1 over x plus 5? Like, I wouldn't. That seems ridiculous. But it is the way it is. Okay, so the other type of question that can be a little tricky for some folks is, what if I do, let's pick much easier, like a much easier range of numbers. X cubed minus 3x plus 1, but this time let's put it over 5x minus 11. So this throws a wrinkle in that my factor on the bottom is going to be a decimal. You can't just say it's 11, because that would not make the bottom 0. And you can't just say it's 11/5 because that ignores... So basically, when your power on the bottom, when your coefficient of x on the bottom is a number, you should factor it out. That's kind of just the tried and true rule. Do that every time, and you will prosper. So if you get that sort of expression, and I guess I should have put an integral on this and a dx, you should factor out the 5 on the bottom, because if you now do this, then you realize 2.2 is your guy that you're dividing into this, and is this going to get a little hairy with decimals? Yes. These are harder. That's why this is a jankier kind of question. So 1, 0, -3, and 1 are my pieces. I pull down the 1, multiply by 2.2, no problem so far. Add those together, still chillin'. 2.2 times 2.2 is 4.84. Add those together, you get 1.84, and that times 2.2 is something. I am too lazy to do that. Am I? This would be a good spot to show the power of box multiplication. 2.2, 1.8.04. Cool. 2, 1.6, 0.08, 0.2, 0.16, and 0.0, let's see, 0.008. Yeah. Okay, and now I just add all these together. So what do I get? 3.6, 3.8, 4.04, 4.048. Whoops. Look at that, we did it. We multiplied those things. Wow. And then you add those together and you get 5.048, and we're kind of done with all the janky mental math here. In that now we can say that this is the squared term, x squared plus 2.2x plus 1.84 plus 5.048 over x. Also notice how I didn't have to have this memorized. Like, look at that. I multiplied decimals in 3 digits by 2 digits and did it the lazy way, and it worked out just fine. Okay, then I raise the power by 1 and divide by the new power, and we're home free. And so, yeah, this is going to be on the quiz when we get back from break. So these were good questions, and why I was happy to go more into detail on these. Now, there's definitely something I did wrong here. This bottom is complete and utter stinking hot pile of garbage, and actually everything in this problem is. So let's talk about what I did wrong here. Because I got a little distracted and just moved forward. Because, you know, that's what you should do. Alright, so my bottom is 5x minus 11. And I only divided everything by x minus 2.2, which means all of these actually have an over 5 in them. And in my haste there, I didn't write it. So when you have a constant on the bottom, your problem's like way harder. Now, you can avoid this, having to put this over 5 over by everything, if you pull this 1/5 out of the integral, and you rewrite your integral as 1/5 times x cubed minus 3x plus 1 over x minus 2.2. And then, if you do this, you just get the answer, and then you multiply it by 1/5 at the end. And that saves you a lot of hassle with having to remember the bottom. But now, if here I have the distributed 1/5 to everything. So I guess I'll just continue with this one. Oh man, this one's like way nicer from an integration standpoint. That's interesting. Alright, so we get x cubed over 15 plus 2.2 x squared over 10 plus 1.84x over 5 plus, yikes. So we have to do u sub here, or we just have to say that this is 5.048 over 5 times 1 over x minus 2.2, which is what I'm going to do, because that sounds way better. Yeah, because that integrates to 5.048 over 5 times the natural log of x minus 2.2 plus c. And yeah, that's a way jankier kind of example. So realize that if the bottom is not clean, your synthetic's a lot harder. Or you can use log division. Or you can factor out a 1/5 ahead of time and then just multiply by 1/5 at the very end of the problem. You can really walk a lot of paths there, but you need to pick one of them. Okay. I got a question. Can you do 8 on the homework? I would be happy to do 8 on the homework. In 8 on the homework, I have 3 times 5 to the x here. And I'm integrating, so yay, integration. If you were here earlier, you can probably just say, yo, this is 3 times 5 to the x over natural log of 5 plus c. Because it is. Because the rule for exponentials with bases that are different than e is you just divide by the natural log of the base when you integrate. If you're not happy with that, remember you can do what we've done elsewhere on this homework, which is to rewrite this as e to the natural log of 5 times x. And then you just do u substitution with u equals natural log of 5 times x. And then you get du equals natural log of 5 dx. And so dx equals du over natural log of 5. So if you're wondering where this divided by natural log of 5 thing comes from, it comes from this. And this is actually, like, if I open up the notes, like, exactly our next notes section is talking about this kind of stuff. We also do logs of different bases, and so that's, like, what I'm going to be doing when I get back. I'm just going to jump straight into logarithms and exponentials with bases other than e. That's why I wanted people to watch this, so they'd, like, get some exposure to this and be ready to rock and roll on this. But yeah, that's what we're doing, is we're taking the derivative of things with other bases. The day we get back. So Monday, because it looks like the snow is not going to grace us with too much. Maybe Tuesday night, but probably not. We may have a late start, but probably we'll just have a normal week next week. Well, I'm going to wait a little bit for perhaps another question, but I think this is long enough. It's not like it's a test. It's just a... Remember that logarithm derivatives and exponential derivatives exist, and that we do them, which was the entire point of this. When is our next test? What do we got? We got this, we got inverse trig, we got inverse functions, and then we're taking a test. So what are we looking at? Probably... the second week we get back from break, we'll have a test. Can you do one of those weird integrals but with long division instead? Thoughts on Apex Legends? It looks nicer than Fortnite. I don't know. I don't really play those games. So next test is the second week we get back from break almost exactly. Is it gamer time after the stream? Probably not. I actually kind of burned out on video games, so I've been doing like housework and applied for my passport and went to the dentist and crap like that. So I've been being reasonably productive instead, because I'm just a little burnt out. But you know, new PoE expansion launches in like 2 weeks or something, and then I have freaking MUN conference. No, I don't. Oh, it's the week earlier. Okay, so anyways, enough distractions. Let's go to Drew's question as my like last hurrah here, where I do a little bit of long division. So yeah, let's do that long division. Let's do 2x minus 11 this time instead of 5x minus 11, and let's put that into x squared plus 5x plus 3, just to make my life a little easier here. What do I multiply 2x by to get x squared? I'd multiply it by x over 2. So you can see how this is different from the get-go here, is I don't need to factor out the 2, because it's really clean to just say, oh, it's x over 2 I multiply by. And then I multiply x over 2 by this stuff, and I get, surprise, x squared. And then x over 2 times 11 is minus 5.5x. I'm subtracting this stuff, so actually I'm adding the 5.5x, and I get 10.5x plus 3. And then I say, what do I multiply 2x by to get 10.5? And that's 5.25. So you can see you get a little jankier numbers when this root is not as clean as just an x minus 3 or an x minus 5 or an x minus 1 or something like that. But the process is really, really similar. So I multiply and I get 10.5x, yay. And then 5.25 times 11 is, what? 52.5 plus 5.25? So 57.75 or something like that. Man, I am not thinking straight today. 0.25 times 11. Yikes. So it's 55 plus a quarter of 11. What is that? 2.5 plus 2.25. Alright, 57.25. I did get it right. Cool. And then I'm subtracting this stuff, so really I'm adding the 57.25, and I get 60.25. So you can see why I don't do this a lot on quizzes. Like, if I do it on quizzes, I'll generally make this factorable, this term we're dividing, because all of this work I'm doing, the thing that makes these hard is just busy work. It's like doing 2 by 2 multiplication or 3 by 3 multiplication, and that's not what I'm interested in assessing. So that's why I generally, if I put a question with a coefficient of x on a quiz, it'll be like 3x minus 12, and it'll be like, hey, factor out the 3, and then just do it easy style. Okay, so yeah, just to finish this question, it's x over 2 plus 5.25 plus 60.25 over 2x minus 11. And this you could integrate extremely similar to how we've been doing it so far, raising the power by 1 and dividing by the new power. Even in this case, when I did it this way, I still wanted to avoid doing u substitution, so I did. You could also get this exact same answer with a 2x minus 11 in here. That's functionally exactly the same thing. That's what you get if you use u substitution with the bottom. Because you get du equals 2 dx, so dx equals du over 2. And then you just get 60.25 over 2, which is 30.125. It is fascinating, and it blew my mind for like the first year I do this, that natural log of x minus 5.5 is functionally the same as natural log of 2x minus 11 if there's a plus c here, because that natural log of 2 factor on the inside just gets absorbed into the plus c, and so it's irrelevant whether or not you have it as long as you have the plus c there. So that's pretty cool, but a little mind-blowing. But yeah, please remember to do u sub when you're doing natural log. Like, the natural log and exponential rules are so freaking easy. The hardest part of them is just doing your u sub right, or doing your chain rule right. Alright, what quizzes are we taking next week? Let's see if I'm going to go to my crutch for that. So let's see, I believe we are on our 27 and 28, I think we're both first tries. I think, gosh, I don't remember. So we're definitely taking 28 again. I think we're taking 27 again, and I think we're doing 29. Which is logarithmic differentiation, I believe. Is that true? No, logarithmic was the bottom one, so it's long division, right? Yeah. So I'm just adding long division to that quiz and taking off u sub. That's the difference compared to the last quiz we did. So it's division, logarithmic differentiation, and natural log derivatives and integrals. That's going to be the stuff on the quiz. Yeah. Is Monday a B day? Yes. Yes, Monday is a B day. Do you have any good online practice tests to use to study for? A lot of the good practice sites have recently gone offline, actually. They're trying to make more money. I use the .io thing. What is that thing called? The not .io. Crap. Yeah, I don't remember. But there are some resources on my website that link to things that have more questions in them if you're looking for more questions. But I just use the Barron's book mostly. Do we need to know L'Hopital's rule for the AP test. Yeah, so Drew, interestingly enough, the reason why I haven't taught L'Hopital's rule is the majority of what L'Hopital's rule is really, really useful for requires you to know exponential and log derivatives to unpack. And so I'm probably going to sneak that in this unit, which probably extends this unit, so maybe into next week is when we test. So yes, we need to know L'Hopital's rule for the test, and yes, I'm planning on teaching it. I just have pushed it off to this point because of the order our book goes in. It just makes so much more sense to me to put after exponentials. Like, because I was an electrical engineer, and I use L'Hopital's rule quite a bit in engineering applications, and it was almost always on exponential functions. So, it also kind of shows how big exponential functions are compared to other functions, so that's pretty cool. But yeah, L'Hopital's is definitely something that is coming up. I debate whether or not to put it in this unit or put it in the end of the year. It's kind of cool to teach something you consider really important but is really easy right before the AP test because it gives people tools to use. But yeah, it does help with limits. It helps with some more than others. But yeah, a lot of people tend to overuse L'Hopital's rule, which is a weakness. But yeah, that's definitely something that's coming. But anyways, I should probably stop rambling. Hopefully, folks will be prepared for that test when we get back from break and feel like they still remember things. I hope you all have a great break for the remaining part. I'm probably going to go do some housework because I need to like build my brother's door, which is a curtain. But yeah, that's stuff to do. So no gamer time for me. All right, have a good day, y'all.